So this is question number 9.5 of ray optics. And the question says a small bulb is placed at the bottom of a tank containing water to a depth of 80 centimeter. What is the area of the surface of water through which the light of the bulb are emerging out? And then the refractive index of the water that is given is 1.33. Consider the bulb to be a point source. So what is the question is saying? You can visualize that by seeing this diagram. So here is the water surface and bulb at a depth of 80 centimeter. A bulb is placed. A bulb is placed, right? And that bulb is glowing. And now you can see this light of the bulb only in a circular area due to TIR. The angle after which the critical angle, the ray will again bounce back inside the water and don't go into the air because of the refraction that is happening there, right? So that is the concept here, and you have to find the area of this glowing circular of radius r, right, that you are going to find. Simple. So this is the idea that in the question given. So first of all, before we start, let's revise the optics that we usually do. So ray optics, in ray optics what we study particularly, this question is coming from total internal reflection, in which the condition is denser to rare. The ray must be going on from denser to rare medium, that is I, and I, that is incident angle, must be greater than critical angle, right? And then sin IC is equal to 1 by mu refractive index, and tan IC is radius by depth, that you can find by using geometry and using optical fiber, prism and diamond. There is also one question in NCERT that is based on this optical prism. You have to define that how TIR works in optical fiber, right? This question generally repeat in board examination. Other than that, basic concept, then a spherical mirror you have to study, then refraction of light, then prism, optical instrument and lenses. So all this concept you have to revise. You can pause and revise all the formula. And today's video agenda is to solve this question. So let's start solving this. Okay. So this in this question particularly, we have to start with the given what is water at depth of 80 centimeter, 0.8 meter, and mu is the refractive index that is given is 1.33 for water, right? Then you have to find so first of all you have to find the area where the light is glowing, right? So first of all, let's see the concept that what is here. So this is bulb, and when the light ray goes from denser to rare medium, it bends away from the normal, right? So the light ray that is going into the normal will pass the normal, right? Simple ray optics rule. And then the light that is going little deviated from the normal, it will deviate more, right? And similarly this way also it is going to deviate more, and similarly the more deviated line will deviate more, the more deviated line will deviate more. And there is a point that will come that the incident angle here will pass the critical angle, and it will become a critical angle, and after any ray that will going to cross that critical angle, it going to bend again in the water, right? So this is going to happen. And similarly this side also the same thing is going to happen. And after that, passing the critical angle here, after passing the critical angle, the light will bend again in the bounce back in the denser medium, right? So here in the case here it is water. So you can only see the light coming out in this particular circular area, okay? And that is the concept that is used here. So you have to find the radius of this circular area, that is going to be your this triangle that you can see here. So the triangle here that is present, you have to find the radius, and that is this side, and this is the depth, right? And by geometry you can find that, you will see in the question. So the concept is this, and I think it is clear to you right now. we are going to use sine I critical is equal to 1 by mu, and then we are going to use tan I critical is equal to radius by depth, right? This can be also get derived, but because the question is going to be, or solution is going to be so long, that's why I'm not going to do that. So let's see the solution. We are going to first find the critical angle for water air interface. So at TIR condition, what we have, I greater than I critical. Here I critical, it the incident ray has passed the I critical, that's why it got bent. Here in this diagram you can see. Then I critical is sine I critical is equal to 1 by mu, that is mu is equal to 1.33, and the value is 0.7519, right? Then I critical is sine inverse 0.7519, and that is 48.8 degree, that you can calculate. Okay, then after that, obviously the calculation in NCERT is going to be real hectic. If this question will going to come in your boards exam, the value will be given there. Okay, so don't bother for that. And second is find radius of circular area on the water surface, right? So only the ray less than the critical angle are going to emerge, right? We can say that also in the diagram, only the rays that has angle incidence angle greater than critical angle can able to pass this circular area, right? So that was written here. And then after that, for geometry, we know tan I critical is equal to r by h, that is radius by depth, radius by depth, right? Radius by this depth, right? So now we have to find the radius. Depth we know, that is given in question 0.8 meter, and you have to multiply it with this, so you are going to get the radius is 0.912 meter. And simple, once you get the radius, it will become very easy for you. You have to find now the area of the surface. So you have the radius of this, and you have to find the area of this surface. Simple, that is going to be pi r square. Applying the formula, area is equal to pi r square, and it is your 2.6 meter square, right? So hence the area in which the light can be seen coming out is 2.6 meter square in a circular area, right? So very simple, and I insist you to please revise this mind map, so that it will also going to help you memorizing and retaining the concepts of ray optics, because this chapter is very large. So with time you are going to lose all this concept. So for retaining that, you have to constantly revise this. Okay, so please pause and revise and see the solutions here that is provided. Okay.